For your makeup assignment this week, what I'm going to do is walk you through the experiment that you missed, and then I'm going to supply you with some data that you can use to perform the calculations. So just to get started here, the formula for density is mass divided by volume. So if you have a sample of a liquid and you know the volume of that liquid, and then you also know the mass, you can calculate the density of that liquid. So in lab, we had to use a balance to determine the mass of the liquid. And the first thing that we had to do, though, was weigh an empty beaker, find out how much that beaker weighed, because then you were going to put a liquid into the beaker, and what you would be weighing at the end was the mass of the liquid and the beaker. So you have to weigh it empty, and then you're going to weigh it full. Volume, well, there's a lot of different ways that you can measure the volume of a liquid in the lab. There's a lot of different pieces of glassware that you can use. The one that we chose to use for lab was a burette. So in case you do not know what a burette looks like, this is a burette. It has graduation marks going all up and down the column of it. And the very top mark of the burette is 0.00 milliliters, and the last mark on the burette is 50.00 milliliters. So you were going to fill this up and use it to put some liquid into the beaker, and you were going to read the burette volumes to determine exactly what volume you put into the beaker. So let's just give you a quick example of the first one. I'm going to walk you through it. The first thing that you do is you fill up the burette, but you don't actually put it on the 0.00 mark. That takes way too long to do. It's very difficult. So instead what you're going to do is read the volume where it starts and then the volume where it ends. So once you've got the burette filled up, you are going to take a really close look at where the meniscus is on the burette. And you're going to kind of draw an imaginary line going across from the very bottom of that curve over to the gradations. And you can see here that my line, which is right at the bottom of the curve, is actually in between two of the burette marks. So to go about reading it, the first thing you have to do is figure out the largest volume mark. Let's try that again. The way that we read a burette is by first figuring out how many tens or ones of milliliters you have, and then we figure out how many tenths of a milliliter you have, and then how many hundredths. So right now, this curve is between 0 and 1 milliliter. So it's somewhere more than 0 milliliters, but it's less than 1. So in the ones place, our burette reading is going to have a 0. For the tenths, each one of those small marks on the burette stands for 1/10 or 0.1 milliliters. And so if you count down from the 0 mark, you'll see that the mark above the curve is 0.5 milliliters, and the one below it is 0.6 milliliters. So the volume in my burette is somewhere between 0.5 and 0.6 mils, which means it's 0.5 something milliliters. But I know that it's not exactly 0.5 mils, and I know that it's not 0.6 mils. Whenever you have a device that has these graduations, you always need to give us an estimate of how far in between the graduations your meniscus falls. So we do that by adding a number into the hundredths place. So if I look at where that line falls in between the 0.5 and 0.6, it's not exactly halfway. It's a little bit less than halfway. I'm going to estimate that that is about 0.03. And so my final burette reading is going to be, or my initial burette reading is going to be 0.53 milliliters. If your meniscus does happen to exactly meet one of those graduations, you need to tell us that by putting a 0 in the hundredths place. So if this had been exactly on the 0.5 gradation mark, you would actually report that as 0.50 milliliters. Okay, so now we know our initial burette reading is 0.53 milliliters. We are going to take our beaker number 1 that we have already massed. We know that that mass is 51.346 grams. And we're going to drain the burette until we've put about 10 milliliters of the unknown into beaker number 1. So I do that. The next thing that you have to do is read the volume on the burette again. I'm not going to go through that again. I'm just going to tell you, you read it the exact same way. And this time, let's say the burette reading is going to be 11.24 milliliters. Last piece of data that you need to calculate the density of the liquid in this beaker is the mass of the full beaker. So the beaker and the liquid inside it is going to weigh 62.891 grams. That's all the data that you need to calculate the density of beaker number 1. So now what I'm going to do is have you guys pull out your lab notebook sheets and go to the data table that is on the back of the first page. And I'm going to stop for a second. You can pause right now until you have that out and ready to go. Okay, so I am going to supply you with empty beaker masses, beaker plus liquid masses, and then the initial and final burette readings that you can use to perform the calculations to get the average density of the unknown. So to start, the mass of that first empty beaker was 51.346. The mass of the beaker and the liquid, 62.891. And the burette readings from that run were 0.53 and 11.24. Note, I'm not putting the units in the column because my column headings where it says massive empty beaker, I put it in the title of that row. So that implies that it is grams all the way through that row going to the right. So now I'm going to give you the masses of the other 4 beakers. You weigh 4 other empty beakers and you get 48.617, 49.158, and 55.636, and 52.125. Then you go ahead and you start filling up the beakers. So for the second beaker, you don't refill the burette. You have more than 15 milliliters left in the burette, so you just keep on going, which means your initial burette rating is going to be the final burette rating of trial number 1, 11.24. You drain it down until it is at 26.71 milliliters, and then you go on to trial number 3. So beaker number 3, you're supposed to put 20 milliliters into. So you aimed for somewhere around 46 mils, and you did pretty well. You got 47.05 milliliters. At this point, you do have to refill your burette because for the next trial, you need to put more than 3 milliliters into it. And your burette only has 3 milliliters to go before it hits 50 mils. So you go ahead, you refill the burette, you drain it down so it's somewhere between 0 and 1 milliliters, and you read where it is, and it's 0.17. Then you let the liquid out into the beaker. Your final burette reading is 30.38 milliliters. You have to refill it again to do the last one, and so it starts at 0.35 and ends at 35.26 milliliters. Then you take all of those beakers over to the balance, you weigh them with the liquid in them, you get 65.185 for the first one, 71.023, 88.082, and then the last beaker is 89.583. That is all the data that you need. You can now calculate the mass of just the liquid because you know how much the empty beaker was and how much the beaker plus the liquid weighs. And for the volume of the liquid, if you started at 0.53 and you went down to 11.24, it's just the difference between those two volumes. So again, it's simple subtraction to find the volume of the liquid as well. Then you have the masses, you have the volumes, you can calculate the density for each one of those trials, take the average, calculate the standard deviation, and you're set. So that is going to be your main task now, is to complete those calculations. Do note there's a spot for sample calculations below the table. I do need you to fill those out. You're going to do it just for the trial number 1 data. We never need to see every single repetition of a calculation. Just the first one is good. Everybody in lab was given these estimated uncertainties, so I'm not going to make you look it up, but do remember, you can look up the uncertainties of our devices in the lab. In the beginning portion of the lab manual, we have a table of all of them. So for a burette, the uncertainty in a burette is plus or minus 0.05 milliliters. And for the balance, it is plus or minus 0.001 grams. So you would write that into the spots for estimated uncertainty. Then you're going to tell me the number of significant figures. And if it is a row where you have some, like if you look at the burette reading before delivery, some of them only have 2 and some of them have 4. That's fine. Just put 2, 4 or something like that. That's fine. So go ahead and complete all of those calculations. And then on the very back of the procedure, oh, I'm sorry, I forgot about that. For the lab notebook sheets, you're going to fill out that data table and sample calculations page. You aren't actually performing this procedure. You're just listening to me talk. So you're not going to write a procedure. You can just leave that lined notebook page completely blank. But I do need you to flip over to the back and fill out the calculation or the conclusions. The biggest part that you're going to struggle with is the error sources, because you really kind of have to be in lab and see what's going on in order to think about it. So I am going to kind of give you an idea of what we're looking for. When you're writing about your error sources in lab, the one thing that we don't want you to write about are things that are called human error. So these are things like, oh, well, I may have misread one of the volumes on the burette, or maybe I plugged a number into my calculator wrong. Those are human errors. Those are errors that are avoidable by simply being more careful when you're doing things. What we are looking for in terms of error is something that is an inherent flaw in the apparatus that we're using, the glassware that we've chosen to use, things like that. And so for this lab, the 2 main ones that I can really think of. First off, when you are draining the unknown into the beaker, a lot of times you end up with little droplets that splash up and out of the beaker. It's kind of like somebody doing a cannonball into a pool. You get a big splash. Well, if some of that unknown splashes out of the beaker, that's going to be a problem. The reason it's an issue is when you think about the way that we calculated our density, the volume, we just read the beginning and the end volume on the burette, and we assumed that every single bit of that liquid that left the burette went into the beaker and stayed in the beaker, and when we weighed it, that was all of the liquid. But if some of it did splash out, that wasn't really all of the liquid. And so the mass that you're measuring is not going to be consistent with the volume, because now your mass is going to be too low, because it's not all of the liquid that left that burette. So now you need to think about, okay, well, if not all of the liquid was in the beaker when I massed it, what is that going to do to my density? So it's up to you guys to figure out, is that going to result in a higher or a lower density if your mass is erroneously low, because not all the liquid was actually there when you massed it. Another one that you can talk about is, well, every time you touch a piece of glassware, you leave a fingerprint on it. And that fingerprint is actually oils from your hand. That is going to add to the mass of your beaker plus liquid. Every time you touch it, you leave oils. And if you touch a beaker 4 or 5 times, you are going to see a mass increase simply because of the oils on your hand. So kind of do the same kind of exercise. Think about, okay, well, now what is that going to do to the mass of my liquid? Is that going to make it too low? Is that going to make it too high if I'm adding oil to the beaker from my hands instead of just the unknown? And how does that affect the density? So that is going to be your lab makeup. So a few notes. Oh, sorry. A few notes here. I would like you to turn your note sheets into me sometime on Thursday, no later than 4 p.m. You cannot turn them in before you go to lab because you have to have that data for lab. You're going to be entering it into Excel. Also, there is no lab quiz this week. We're going to do the density lab quiz next week when we come back the week of September 24th. And that is it. So do make sure that you bring your note sheets to lab, and then make sure you get them turned into me after lab no later than 4 o'clock on Thursday. I will get them corrected and get them back to your lab instructor in time for you to be able to reference them for the quiz. The other thing is, please, if you have a laptop that has Excel on it, we would appreciate it if you could bring it to lab next week. When we're doing the computer exercise, we have a computer lab that has 24 computers in it. That's not enough to accommodate the 36 students that are in our lab sections. So please bring your laptop if you can, as long as it has Excel. If you have any questions, please email me, and I'm just going to write my email address out really quick. It is egregory@brockport.edu. And that is it for the makeup assignment. I hope you do well. If not, if you have any questions, do email me. Bye.